Good morning. We're going to go ahead and start with some new material, talking about tangent lines and circles. Since you guys already had tested out of um, the inscribed angles and stuff like that, we're just going to go ahead and move on with this new material. But I did want to go ahead and go through the warm-up with you on these because I do need to kind of just remind you a little bit about what these are. So if we're looking at angle 1 right here, if I'm looking at angle 1, we can see that this is going to have, hang on one second, let me drag this over. My pen, the way that this tablet is set up, is not giving me exactly the distance that I want on the screen here. All right, so let's try this again. So when looking at angle 1, if I'm looking for angle 1, because it shares the same arc as this angle 60 does right here, it shares this arc, then if this is 60, angle 1 would also be 60. All right, because they share the same intercepted arc. All right, angle 2, again, because this angle right here, angle 2 has an intercepted arc of 40 degrees, then angle 2 will be half of that intercepted arc. Remember that an inscribed angle, the vertex is on the circle itself. The arc is twice the angle, and the angle is half the arc. So this would be 20. All right, so again, because these two angles right here share this intercepted arc, then angle 2 is going to be congruent to angle 3, so angle 3 would also be 20 degrees. And so if angle 2 is 20 degrees, then we could see here that if this was 20, this was 60, angle 4 would be 100 degrees because we would go ahead and add the 60 and 20 gives us 80 for a triangle. Subtract from 180 degrees, this is going to be 100 degrees. All right, so for number 5, this is a little bit tricky right here, but if this is a central angle, then this angle is equal to the arc. So if this angle is 8x minus 4, the arc itself is also 8x minus 4. All right, so let's go ahead and put that in there. So 8x minus 4. Okay, so now if this is my inscribed angle, 2 times the inscribed angle is the arc. And then I would just solve for x. Plug it back in. All right, so let's move on to tangent lines here. So a tangent line is a line that is actually outside of the circle and only intersects the circle at one location. That one location that the line intersects the circle is called the point of tangency. Now, if I have multiple circles, they can have multiple tangent lines, of course called common tangent lines. So we can see here, this is a common tangent line. They're going to intersect the circle at 2 different locations. This one right here would actually have more than one common tangent line, right? I can go ahead and draw a tangent line that goes right here. I could draw a tangent line that goes right here. And we could also draw another tangent line that goes right there as well. All right, so those two circles are going to have 4 common tangent lines. These two circles over here, well, they would have 3 common tangent lines. All right. All right, so let's look at this right here. So if I have a radius that connects to the point of tangency on a tangent line, that radius makes it perpendicular. All right. So Right? So if ST intersects line L, then ST is going to be perpendicular to line L. If and only if L is a tangent line, of course. So if I want to verify whether or not LM is a tangent line, if LM is a tangent line, then KL would have to be perpendicular to it. So if this is going to be perpendicular, this would have to be a right triangle. So then I would say 29 squared is going to equal 20 squared plus 21 squared. And so we would have to see whether or not that's actually going to be true or not. So let's take a look at that. So pulling up the calculator. So we have 841 equals 400 plus 441. And in fact, 841 equals 841. Therefore, LM is a tangent line. LM is a tangent line because KL is perpendicular to it. So that's what we would do in a problem like this. And this is the type of problem that you're going to see on your assignment right here. We would want to check whether or not AB is a tangent line. Well, if AB is going to be a tangent line, then this has to be a right triangle. So therefore, 10.6, sorry, let's do that again. .6 squared would have to equal 5.6 squared plus 9 squared. Where did I get that 9 from? Well, the 9 is, if this radius right here is 4.5, then the whole diameter is going to be 9. And so I want to check if this is true, then this is a tangent line. Okay, so if I'm looking at how I would do a problem like this, where I have x for this segment right here, this is my radius, and 16 is this segment right here. If I wanted to go ahead and find the value of x, well, this whole side right here would be x plus 16. All right? That's what the value of this side of the triangle is. So therefore, we would say, in order to find the value of x, that x plus 16 squared is going to equal x squared plus 24 squared. All right. Now, I'm not going to go through this work right here because I'm not going to give you problems like this that are going to have quadratics and stuff. I just wanted you to see that when we were working on a problem like this, when you have this segment right here and this segment right here added together, that's going to give you the whole thing of x plus 16. All right, so if I have two tangent lines, I'm going to assume that these two are tangent lines. And I have a point anywhere outside of the circle itself. In this case, that point is B. The distance from the point of tangency is the same on both of those. All right, so the distance, so if AB, hang on one second. So if AB and CB are tangent lines, then the distance from AB would be congruent to CB. All right, so that's our rule here. All right, so looking at a type of sample problem that you're going to have off of your assignments, we'd be looking at something like this. Okay, again, it's the same scenario where I have AC and BC are tangent to circle Z. Find the value of X. Well, if these two are tangent lines, and I have a point outside of the circle, then the distance from the point of tangency to that point is the same for both. So we would just say that 3x plus 2 is going to equal 4x minus 3. All right, solve for x. All right, so looks a little bit more complicated, but really no different. All right, this is the same thing. We're saying, okay, well, I've drawn a few more lines in here with the radiuses, okay? But, again, I have a point of tangency right here. I have a point of tangency right here. And I have a point outside of the circle right here. So therefore, 5x minus 1 is going to equal 4x plus 1. And then we would solve for x. So you have to assume when we're looking at a picture like this that I have points outside of the circle. All right? And so the distance from the point of tangency to that point outside of the circle is the same as the point of tangency to that point outside of the circle. Point outside of the circle to the tangent, point outside of the circle to the tangent. These are all the same. Sorry guys, when you have kids running around and you're trying to do this, this is kind of its own form of chaos here. I'm ready to go back to school, I think. Anyways, so let's go ahead and fill this out. So if I wanted to go ahead and find all of my missing sides, because eventually you will have to find the perimeter of this polygon right here, this quadrilateral, this kind of perimeter, so add up all the sides. So let's just fill these things out in the sense that, remember that if this is 4.3, this is 4.3. If this is 4.3 and the whole thing is 16.3, then this segment right here is 9. Well, if this is 9, this would be 9. And if this is 9.2, of course, this is 9.2, which means this whole side right here is 13.5. And if this is 9.2, then 9.2 minus 17.4 is going to give me 8.2. And this would give me 8.2. So this whole side would be 17.2. So now I have the length of the sides of this quadrilateral. So I have 16.3 is this side, 17.2 is this side, 17.4 is this side, and 13.5 is this side. So the perimeter of this polygon is adding up all 4 of those sides. So let's go ahead and add them up. So we have 17.2 plus 16.3 plus 13.5 plus 17.4, and that would give me a perimeter of 64.4. All right, 64.4. All right. I think that's going to be it. So if you have any questions, email me. I'm going to go ahead and post your assignment on CUDA Classroom. And again, this is, keep in mind, guys, that the reason why we're doing this CUDA Classroom is because most of your assignments, even in class, are done off of that CUDA software program that I use. So it seemed logical that that was going to be the best form to use when it comes to posting your assignments. And it's a pretty good software program because it gives me back your grades. So for right now, of course, all your grades are participation grades, but pretty soon we'll start being able to do assessments and actually grading them for accuracy and stuff like that. So try to pay attention to it, do the best you can, and then email me. We can set up a Google Meet or something like that if you need any questions or have any questions or want to work through some of the problems together. Okie doke. Take care, guys. See ya.